Hi again. So I'm Ashwin. I'm going to talk with you a little bit today about conversational AI. You've probably all seen quotes like this: "The age of touch is at the end," "Something new is on the horizon," et cetera, et cetera. If you look at where we've come in the computer land, for decades we've been typing at our computers. That's the primary mode of interacting with a computer. For the last 10 or so years, we've been touching and swiping with the advent of the smartphone. And slowly that has now permeated to other kinds of technology, not just phones. About 2 years ago, with the advent of Alexa, voice became a game changer. And of course, there was voice interfaces before that, where Alexa did something, and what I want to do with you today is share with you what we did and what the game changer has been. So the vision behind Alexa is really this, that when we communicate with technology nowadays, we have to learn the technology. We learn user interfaces, we press buttons and dials and all of that stuff. But why don't we have machines learn about us instead of the other way around? So if I'm talking to you, if I want to communicate with you, I'm not typing at you, I'm not touching and swiping and turning dials, I'm just talking. Let's do that with our machines as well. So that's where Alexa comes in. Right? In fact, I brought Alexa with me. I'll have her, assuming the Wi-Fi works in here, let's have her introduce herself. Alexa, introduce yourself.
I'm Alexa, and I'm designed around your voice. I can provide information, music, news, weather, and more.
So that's Alexa. She comes in this form factor. She also comes in an Echo, the little things you've seen recently, the dots on tablets, on your television, and I'll show you increasingly other kinds of devices. The magic that made Alexa possible was this far-field voice recognition technology. So Alexa sits in your house. It's not in your phone, right? It's not in your computer. It's just sitting out there in your house, and you talk to it naturally across the room like you would talk to any person. And there might be other people in the room. There's music playing, maybe your oven's going off, or there's conversations going around. It doesn't matter. Alexa picks up your voice and talks with you. And that's the far-field technology that we invented. What does Alexa do? Pretty much about everything. Initially, there was a lot of emphasis on music and shopping, as you would expect from Amazon. So Alexa will play music, not just from Amazon, from Pandora, Spotify, TuneIn, really whatever you like. A lot of people use Alexa for household organization, shopping lists, timers, alarms, calendars, those kinds of things. Alexa gives you information, news, weather. You can ask it any question pretty much, and she will have an answer for you. A lot of usage around smart homes. Alexa will control your lights, lock your front door, close your garage, those kinds of things. In fact, there are over 10,000 skills developed by third parties. Alexa will get you pizza, play games with you, like Jeopardy and others, check your bank account, get you coffee, and a whole lot of other things. In fact, these are some of the popular skills we have. You can get flowers for Mother's Day. You can get a ride from Uber. Alexa, get me an Uber, and the Uber shows up. No more swiping, touching, working with apps anymore. Right? So that's the vision behind Alexa, locking doors and so forth. So the way this is made possible is through a service we call the Alexa Skills Kit. So Alexa lives in the cloud, and you interact with Alexa through voice. Your interactions then get routed to these skills that then fulfill the request, and I'll show you how that works in a few minutes. So if you want to add a capability, your Domino's, you want to add pizza ordering capability, you build a skill for Alexa, you plug it in, and now millions of Alexa customers automatically have pizza ordering capability. We also have another service called the Alexa Voice Service that lets you embed Alexa in other devices. So of course, you can get Alexa in things like this that Amazon makes, but you can also get Alexa in watches, in your car, in video communicators. That's the bottom right. That's made by a company called Nucleus. In the middle there's a kitchen appliance, a kitchen device that Alexa enabled. So Alexa can actually live inside other devices as well. And at CES this year, there were dozens of devices like this announced. So Samsung's going to have Alexa-enabled fridges. You can ask your fridge if you're out of milk, and the fridge will talk back with you. So the idea is that any device can become an endpoint for Alexa, and all these other kinds of examples. Dish Network, another very big announcement. So we are running out of space for all of the partners that are incorporating or have incorporated Alexa, right? And so if you look at what people are doing with Alexa, a lot of the kinds of applications I showed you earlier. My favorite is actually the top right. Most Alexa devices are used by multiple people. This is really the first computer for years that is not a personal computer. It's a computer in your house. It's a friend. It's a member of your family. You talk to her. So this is where AI comes in, right? So we have this huge opportunity for AI. Imagine millions of people interacting with dozens of Alexa endpoints, interacting with tens of thousands of capabilities. It's a mind-boggling number of different use cases and types of conversational interactions. Everything has to be done through voice and through natural human conversation, right? So let's talk about why this is hard, right? Language understanding is the hardest problem we know. We have self-driving cars. We have all kinds of fancy AI out there in the world. We don't have a computer that can speak like a 5-year-old can to each other, just normal, natural conversation, right? So why is language so hard? So let's look at some of the hard problems that we are solving with the Alexa platform. Speech recognition is the most basic one. So you have Alexa sitting in a house, there's a party going on, there's music playing, your friends are talking, and you say, Alexa. Alexa has to pick up your voice, zoom in, zero in, and pick up your speech sound and cancel everything else. Hard problem there. Okay? And now we have to figure out what the request is. So Alexa, you're in a party, Alexa, play some Pink. What does that mean, play Pink, right? You're trying to play a piece of music by a band called P! NK. Alexa has to figure that out and play it for you and get that thing right. Harder problems. Let's try this one. Alexa, who was the US president when Obama was a teenager? Anyone know the answer?
Jimmy Carter, Ronald Reagan, Richard Nixon, and Gerald Ford were the U.S. presidents when Barack Obama was a teenager.
So we have to do inference to answer these questions. There is not a Wikipedia page you can look up which will tell you the 4 presidents during Obama's teenage years, right? So a lot of understanding has to be done to understand what you mean and then construct an answer for you. Why did you say it? If you say, Alexa, is it hot outside, right? The answer is no. But that's probably not what you intended. What you really meant was, what's the weather like? So your intent was to ask about the weather, but you didn't ask about the weather. And so we have to figure out what's in your head when you're asking that question and then give you the right answer, which is something like it's now 42 or whatever it is outside in Mountain View. So that's basic speech interfaces. When you start getting into conversation, it gets even harder, right? So let's talk about some of the challenges with conversation. Alexa, I want to see a movie. Now, Alexa has to talk back with you. What's the right response here? Right? Turn on Netflix on your television, find your movies nearby playing at a theater, ask you what kind of genre movie you want to see, ask you who you're watching a movie with so you can recommend something appropriate. There's a whole conversation you can have around that. So figuring out sort of why you're telling me this, why are you stating this, is a hard problem. We do it naturally with each other all the time. Context modeling, right? What do we both already know that's in the context that we can refer to? To save time, I won't go through this exercise. You can try it. So who's Barack Obama? Barack Obama is the whatever, right? Who's his wife? Where was she born? Or when was she born? She's a hard problem here, right? Figuring out who she refers to, because the user has never mentioned Michelle Obama. And yet, Alexa knows that you know that we're talking about Michelle. And so it's in what we call the shared context of the conversation. So we have to maintain context and unpack that context as we go along, right? When was he born? Now we're back to Barack again. So here's another contextual problem. Alexa, what's 42? Anyone knows? Oh, so internet.
42 is the answer to life, the universe, and everything. The trick is knowing what the question is.
So this makes sense because we have a lot of shared context, cultural context, not dialogue context anymore, shared knowledge, and that we can riff off of when we talk with each other, and we'd like Alexa to do the same thing. And this question may not make sense if we're from different cultures and we don't have that shared understanding. Right? Response generation, Alexa, I'm bored. Right? This is one of the hardest problems. What is the right thing to say here? Right? So we tackle all of these kinds of problems in Alexa to give these millions of people on these dozens of devices that magical experience of just speaking with Alexa just like with another human being. That's the ultimate goal. Okay, so here's how Alexa works. So we say, for example, Alexa, is it hot outside? The device is doing only one thing, which is listening for her name. Not doing any audio processing, no streaming. So we call that wake word detection. That's that sort of figuring out on the device that you're speaking to Alexa. After that, your voice gets sent up to the cloud. And it goes through speech recognition to figure out what the words are that you uttered based on the sound waves that came up. So in this case, it is it hot outside? We then go through natural language understanding to figure out your intent. In this case, it's the weather intent. We go through some processing to figure out the rest of the intent. You didn't ask where, I didn't tell you where I wanted the weather. Maybe it's where I'm sitting right now. Maybe it's what I just said in my previous talk. I have to figure that out. And then finally, I get an answer, and that gets spoken out in speech. And if this were a longer talk, I would show you some of the technologies behind each of these boxes. There are folks here in the AI nano degree at Udacity, which is absolutely marvelous. You'll be learning to build every one of these boxes yourself, hands-on, in the next 6 months or so-ish, is it? Okay, so I'll just conclude with sort of how you use Alexa. I mentioned the skills kit if you're a software developer and you want to add capability, voice services if you're a hardware maker and you want your device to be voice-enabled. We also have the Alexa Fund for startups. If you had interesting ideas with voice, Nucleus, the voice communicator, was a startup that we funded through the Alexa Fund. And then final slide, we have the Amazon Alexa Prize for students. This is a $2.5 million competition to build a skill for Alexa that can converse engagingly and naturally with you about daily topics like politics, sports, entertainment, etc. There's a $1 million challenge prize if you can engage users for 20 minutes. And we have 18 teams from these colleges competing in it right now. In about a month, these skills will be available for all of you to try. Love for you to try them, give the teams feedback, and help them improve. Okay, so that's the end. So since we do have some students here, let me take 5 seconds to give you a piece of advice. If you do want to contact me, don't send me a generic one-click LinkedIn or to anybody else you want to contact. We get dozens of those. Take the trouble to write a short introduction so I know who you are, and I'd be happy to talk with you. Thanks very much for listening.